Mr. Chairman, co-chairman, ladies and gentlemen, here is my disclosure. Well, aims of our study were to investigate the 3D sacral morphometry of the third sacral foramen and to develop a method of 3D implantation of tine lead electrode. For our study design, we use CT scan of the sacral bone in 3 planes and a DICOM for image processing. As you can see, inclusion and exclusion criteria are shown on the slide. The morphometry of the sacral bone investigated coronary axial and sagittal projections. We use 3 important points: the lumbosacral junction, mediasagittal sacral plane, and foramen S3. The 3D model of sacral bone was created preoperatively. The prospective study included 132 patients. The mean distance of the lumbosacral junction and the foramen S3 was 72 millimeters. The mediasagittal sacral plane and the foramen S3 was 11 millimeters. The next variables are shown on our slides. As you can see, there are no statistically significant differences among right and left sides. We found that the 5% of the foramen S3 has a height and width of less than 5 millimeters. We believe that this one is a very important clinical significance. We use 3D implantation technique in the 8 patients. Implantation time was shorter as well as exposure to radiation. The 3D model of sacral bone was formed as a planimetric basis for the creation of the sacral bone model by using a 3D printer. The morphometric analysis determined the variability of the foramen S3 localization. As you can see on the slide, that there are no differences. There are no differences on the left and right sides, but still there is a big variability. In our conclusion, the 3D sacral bone model allows shortening the implantation time, correct positioning of the tine lead electrode, and the very important point is to reduce amount of radiation exposure to patient and to physician. Thank you for your attention.
Questions from the floor? One question that I had, I enjoyed this paper, and I think it has a lot of practical application. Why not use a pelvic MRI to model the system for each individual patient? Would that speed you up even more?
In our clinical practice, it's done, of course, according to government rules. We must use CT scan before each implantation. Therefore, we use such measurement for creation of specific model. Therefore, using CT scan, we can do a planimetry, and after that, we can do a measurement online of such C-arm. Of course, we can use O-arm, but this one is more expensive, and it's usually done in neurosurgery, but this one is very higher exposure radiation as on, let's say, urological CT, urological S-arm, C-arm, yeah. Therefore, this one is an advantage for us, and we believe this could be a better for beginner, not to use, for instance, C-arm 1 hour, because it's a very long procedure.
Congratulations. It's a very interesting one, and many attempts have been done to improve quality of puncture. I just would like to know, what is your definition of correct positioning? Is it anatomy or clinical result?
Of course, clinical results. Usually this one is only for correct positioning of electrode, and then we must do control both sides as usually. But basically we don't use general anesthesia, but only local anesthesia. Therefore, my answer is to use only paresthesia. for evaluation. But this one is only for good positioning of electrode, not for clinical evaluation of patient.
Thank you for the paper. And one question. And in pediatrics, we have a concern with the occult spinal dystrophy in order to predict the results, because we observe patients with very good response and patients without any response. One methods that could be useful in order to predict is the diffusion tension imaging that was suggested by the colleagues of Utrecht in order to define the structure of the sacral nerves. And do you think, in your experience, that your methods could be useful to predict the success of response or not?
I don't know, because primary, I'm a urologist for adult patients. Yeah. But our colleagues, they have problems with such a type of patients, but could be a new challenge for us to create anything like that. But at present, I cannot answer you because I am for adult patients.
Okay, thank you very much.